Good morning, friends. This video is going to be on how to determine if a relation is a function. And I have up the notes that you can find in Canvas. The notes, the definition is, for every input there is only one output. Or the way people like to say that mathematically is, for every x there is one and only one y. And basically what it means is, if it will pass a vertical line test, then it is a function. So let's talk about a vertical line test. I need a thicker, there we go. If we look at this graph, if I were to take a random vertical line and drop a vertical line in here, then this vertical line intersects this graph right here. The orange vertical line only hits the blue graph once. And even if I decide to move the line, as I move the line, there is still only one intersection point. So as I move the line here, there is only one point where they intersect. If I move the line here, there is only one point where they intersect. So no matter where I move this line to, the line and the graph will only have one intersection point at every move. So for every value of x, there's only one value of y. To contrast that, what if I take the vertical line and I decide to put the vertical line on this graph? When I put the vertical line on this graph's vertical line hits the blue curve in two places. In other words, when x equals 1, y equals -1. But up here, where x equals 1, y equals 5. So when x is 1, there are two values of y. So this is not a function. If I continue to move that line, if I move it over here, that line will intersect the graph in two places. It will intersect it right here, and it will intersect it right here. That would be when x is -2, y is 7 7/8. That would be this point right here. And then this one would be when y is -2, x is 1, 2, 3, almost -4. Let's say -3 3/4. So x is -2 there and x is -2 there, but the y's are different. There are two of them. So that is not a function. Okay? And that's what all of this over here is explaining. And we can give it to you as it looks like a graph, or we could give it to you as it looks like many, many points. So there's various different ways we can list relations. If we look at this, all we're going to do is we're going to look at the x values. This is the only time there's a -5. But right here, x is 0, and right here, x is 0, but there are two different y's. Notice that this time when x is 0, there's a y equals 2, and this time when x is 0, there's a y equals 3. So this is not a function. If you were to graph it, I wonder where my black went. Huh. My colors are all messed up. If you were to graph it, this is your x-axis, this is your y-axis. If you were to graph it, then you would have a graph at 0, 2, which would be about right here. And then you would have a graph at 0, 3, 0, 2, 0, 3. And if you'll notice, put a vertical line through it, the vertical line hits the graph twice. So that is not a function. If you look at this list is going to be a function because none of the x's are repeated. That's a -6, that's a 2, that's a 3, that's a 6, that's a 7. None of them are repeated, so this is a function. It would pass the vertical line test. For every y, for every x, sorry. Every x, there is only one y. Okay. Oh, if we look at it like a picture, if we were to put a vertical line through here, get a little thicker line. If I put a vertical line through here, the vertical line only intersects once. If I move that line, I hit it once, I hit it once, I hit it once, I hit it once. This is a function. That wouldn't be that large. This is a function. It passes the vertical line test. If we look at this one, if I were to drop a vertical line, let me drop a vertical line. There's a vertical line. As I move the vertical line, there I hit the graph only once. There I hit the graph only once. But here I hit the graph twice. Here I hit the graph right there. Here I hit the graph right there. If I were naming points, this would be the point 5, 1. This would be the point 5, 6. So I would say that this is not a function. When x equals 5, there are two values of y. If you were to list them as a set of ordered points, we would have 5, 1 and 5, 6, and they wouldn't work. If we look at, okay, these are called maps. And to do these, all we really need to do is look here and notice that this -4 only has one line. This -1 only has one line. This 2, this 5, this 6. So this is a function. If you were to list it as a set of points, it would be listed as -4, -4. -1, I'm sorry, -1, -4. This should have been -4, 3, my bad. And then you'd have 2 goes to 2, and 5 goes to 1, and 6 goes to 5. So each of these are only -4 only shows up once. -1 only shows up once. 2, 5, and 6. That makes this a function. If you go to this one, and you look at this one, it is not a function because, oh, yes it is. It is also a function because -3 goes to 2. 2 goes, each one of these only has, whoops, followed that one the wrong way. Each one of these only has one going to it. If you wanted to say, well, what would it look like if it didn't? Well, that's pretty simple. If we would put another line here, if this would have had, let's say, another line coming from 5 to 2, then that would make it not a function. And that would be because the number 5 is going in two directions. It's going here and it's going there. So that would be an example of when it's not a function, if that were the case. We've already done that one. So let's look at this one. If I put a vertical line in here, I need a thicker line. If I were to put a vertical line in here, and I were to move the vertical line, we always go from left to right. So as soon as I get to right here, that makes it not a function. So this is not a function. And the reason it is not a function is because when x equals -6, there are many y's. If you look at it, let me move this ever so slightly out of the way. At -6, we have points. We have -6, 2, -6, 1, -6, 0, -6, -1, -6, -2, -6, -3, -6, -4. So all of these values, everything on this line fails the vertical line test. So that is not a function. This one, however, let's see if this one, if we drop a line on this one, if we drop a vertical line and move it across, it only hits once there, once, changes direction. It still only intersects once at a time. Even right here where it looks close, it's still only one intersection point. So this is a function. It passes the vertical line test. Okay. So this is a function. If you graphed it, it would be a graph of a positively sloped line. That is a function. This is not a function. And it is not a function because of that right there. That's what makes it not a function. It makes it not a function because the y has a second power. So if we solve for y, this would say y squared equals -x squared -36. The way you get y by itself is to do that. If you were to graph this, the graph of this would be a parabola that's been tipped on its side, and it would fail the vertical line test. That's why it is not a function. Okay? This one is a function. It is a function. Right here is y. Y doesn't have any crazy powers with it. Y is not inside an absolute value symbol. So that would be a function. If you were to solve for y, you would have 4x plus 8y equals 10xy. And then that would be 8y minus 10xy equals 4x. And then you would have y with 8 minus 10x equals 4x. And then you would have y equals 4x over 8 minus 10x. And when you graph this, I'm not really sure exactly what this graph would look like, but the graph would look like this. And it would pass the vertical line test. So that is a function. Over here in the notes, it defines all of this information for you. It tells you how to do it if it's a picture. It tells you how to do it if it is a set of points. And it tells you how to do it if it is an equation.